NASA says its Traveler 1, the most faraway human-made object in the universe, is sending usable information to Earth again. In the universe, we have no thought what it is, aside from the fact that we can check it. Pioneer 1, the famous space test sent off by NASA more than 4.5 decades ago, has as of late conveyed back a message that has sent shockwaves through the academic community. Following nearly 14 billion miles of travel from Earth, Adventurer 1 has made a revelation so significant that it has changed the direction of its mission, pivoting toward our planet. Join us on this fascinating journey. 7 minutes ago, Traveler 1 made a disturbing discovery and pivoted toward Earth. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a significant anomaly, or something even more improbable? In this captivating analysis, we will uncover these staggering revelations as Pioneer 1 has just made a surprising discovery that caused it to suddenly pivot toward Earth. If certain celestial events hadn't aligned, two of the most astonishing rockets ever sent might never have left Earth. In this case, it was the 4 biggest planets aligning in our solar system about 60 years ago. These planets were slowly aligning in a way that had last occurred during Thomas Jefferson's administration in the 19th century. This fascinating planetary arrangement went largely unnoticed at first. The first person to recognize its significance was Gary Flandreau, a doctoral student in flight at the California Institute of Technology back in 1965, when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most effective method for sending a space probe to Jupiter or even farther to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made an intriguing discovery. In the late 1970s and early 1980s, all 4 planets would align in such a way that they could be visited in a single mission. This arrangement meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau confirmed that this arrangement would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only happened once every 176 years. To seize this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 spacecraft to make the journey, Adventurer 1 and Wayfarer 2. These twin spacecraft were sent on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Adventurer twin tests on September 5, 1977, was truly remarkable. At a place called Cape Canaveral in Florida, Adventurer 1 embarked on its incredible journey into space, launched by a powerful rocket known as Titan III or Centaur. Just 15 days later, Voyager 2 was launched on August 20, 1977. Voyager 1 began its journey into the vast universe following a shorter path. Their primary mission was to explore the giant gas planets in our solar system, like Jupiter and Saturn, along with their numerous moons. However, these fearless space explorers exceeded all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke several records on their inspiring odyssey, venturing into a region known as interstellar space, a completely unknown area within our galaxy. These exploratory spacecraft, Pioneer 1 and Adventurer 2, are now more than 12 billion miles from us. Despite their vast distance, they continue to astonish scientists with the incredible discoveries they make out there. Most recently, they have made a revelation so surprising that it has left everyone in shock. Years ago, the Voyager spacecraft amazed researchers by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers initially believed to be dull and pitted like our own moon, turned out to be vibrant hubs of activity. Adventurer 1 reached Jupiter in March 1979, just 18 months after its launch. Pioneer 2, following a slightly different path, arrived in July of that same year. Both spacecraft were equipped with special cameras that used filters to capture full-color images. Interestingly, they were designed to be extremely steady, rotating through space at a rate more than 100 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, The Voyagers took more than 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For example, Europa, one of Jupiter's 53 named moons, was found to have a fractured icy surface estimated to be more than 60 miles thick. As the spacecraft left the Jupiter system, they received a speed boost of 35,700 miles per hour from a gravitational slingshot, a simple maneuver that moved them toward interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's magnificent rings and endured a multitude of impacts from tiny dust particles before flying by Titan, a moon surrounded by an orange haze, and traveling north out of the plane of the planet's rings. Pioneer 2 continued its individual journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Pioneer 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's accomplishments were overshadowed by tragedy. Just a short time after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after launch, killing all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Voyager 2 flew over Neptune's stunning sky-blue methane atmosphere, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar system, with surface temperatures plunging to a staggering -235 degrees Celsius. The moon's frozen volcanoes were another remarkable discovery, shooting nitrogen gas and fine particles up to 5 miles into its atmosphere. After Pioneer 2's stunning images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the mission's official end, NASA extended the mission in hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft were set to continue their journey into the unknown. In August 2012, Voyager 1 achieved a remarkable milestone by crossing beyond the heliosphere, a vast region of charged particles created by the Sun. This astonishing accomplishment became widely known the following year when a study was published in the journal Science. In 2013, Voyager 1's plasma wave instrument detected strong fluctuations between April 9 and May 2013. This event caused electrons near Voyager to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found inside the heliosphere. At first, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, scientists explain that the electron density at the edge of the heliosphere is much lower than on Earth's surface. By analyzing Voyager 1's data, researchers pinpointed the spacecraft's exact flight date as August 25, 2012. This determination was not based solely on electron movements but also on measurements of charged solar particles collected by the spacecraft on that significant day. For the Voyager team, this announcement was a source of immense pride and satisfaction. Susan Dodd, the project manager, expressed the team's excitement, saying, "We are thrilled to have been able to continue working with the Voyagers and to see them achieve the incredible feat of entering interstellar space." Ed Stone, a key figure in the Voyager missions from the very beginning, emphasized the significance of this achievement in advancing our understanding of space. He said, "Voyager has led us to new discoveries by giving us the first view of this new region, expanding our scientific understanding of the nature of energy and radiation in space." Voyager 2 also crossed into interstellar space in November 2018, venturing into an unknown region beyond the Sun's protective bubble, which shields us from cosmic radiation. However, the truly astonishing news comes from Voyager 1. After an incredible 46 years, NASA's Voyager 1 spacecraft, the most faraway human-made object in space, continues to send valuable data back to Earth. Despite its incredible distance of over 14.7 billion miles, the spacecraft remains operational, even though its primary mission ended long ago. But here's where things get truly interesting. Voyager 1 has recently made an extraordinary discovery that has left scientists both puzzled and deeply concerned. As Voyager 1 traveled through space, something strange happened. It began sending data back to NASA, revealing an anomaly in its trajectory. The data it received indicated signals containing information about an unexplored world, a peculiarity that defied explanation. This anomaly seemed to suggest a massive, previously undetected object exerting a tremendous gravitational pull, bending the spacecraft's path. This discovery has shaken mainstream scientists to their core, sparking a whirlwind of speculation. Could it be a rogue planet, a black hole, or something entirely extraordinary? The implications are staggering. If confirmed, this newfound object could challenge our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, using all available resources to examine the data and possibly redirect Voyager 1 to gather more information. This unexpected turn in Voyager 1's journey serves as a reminder of the vast mysteries that lie beyond our planet and the relentless spirit of exploration that drives humanity to seek answers in the far reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had a projected operational lifespan of 4 to 12 years. Remarkably, Voyager 1 has far surpassed expectations, continuing its mission for an astonishing 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce power through the heat generated by the radioactive decay of plutonium-238. Despite this remarkable perseverance, NASA estimates that by 2025, the Voyager spacecraft may no longer be able to generate enough power to operate its instruments and transmit data back to Earth. During routine communication with Voyager 1 through NASA's Deep Space Network, something extraordinary happened. After more than 40 years of continuous data transmission, NASA's computers on Earth began receiving a strange signal that left everyone concerned. For the first time in its mission, Voyager 1 suddenly stopped its journey and performed a complete 180 degrees turn.